Do you remember, anyone remembers this table from yesterday? These are the compositions of 4 fly ashes from a Brisbane company, Cement Australia Brisbane. So whereas in the previous one, you have some average composition, but here, if you take a look at it, you can see the silicon oxide is very high in all those things, all right? And calcium oxide is much less. So these are typical types of structure, and the LOI is around, maximum is about 1%. So these materials have LOI. So they are about gray-black type color, not very dark. So I just thought I will put this slide just to give you a reminder of how fly ash variations can be. Okay, so this is from one of the slides from yesterday. Now, table 7 is this one. From table 7, it is clear that chemical compounds present in pozzolan materials and in Portland cements are the same. But still, Portland cement differs from fly ash in certain aspects. Okay. Fly ash is amorphous in nature because of rapid cooling, whereas cement in crystalline forms is in crystalline form because of slow cooling. Now, this is something which material scientists would know more, because you do a lot of crystallization and cooling time. So if you have cooling things, that means if this is a classroom, and if the people come in slowly, you can actually select your thing and you can form a structure. So it needs time for a material to form crystalline things. So that's why if you quench a polymer, or if you quench a metal, the crystallinity is decreasing. But it will always try to have crystals. If it gets some extra heat later on, it will start doing something like that. Okay? But fly ash is amorphous because it's from the high temperature furnace, and it just goes outside and it gets, so it has cooled properly. This is quite interesting. Though fly ash and cement contain same elements, but relative amounts of each element is different. The main considerable change is in amount of calcium oxide and silicon dioxide, okay, which is discussed later. So, although, as we say, that chemical compounds present in pozzolan cements and Portland cements are the same, so that is where I think the questions were going on, but like all these questions which are going on. But I held that I didn't show this slide before because I wanted that question to come up and all the discussions went on. And now I have some answer here, because fly ash is an amorphous material. So if it's an amorphous material, what is the difference between an amorphous and a crystalline structure? A crystalline structure has fixed atom-to-atom distance. Good. I have so many answers from there. Fantastic. Thank you. The crystalline thing is much more ordered, whereas amorphous is disordered. But amorphous is disordered, that means you can change it also, or things can go inside. An amorphous structure also has advantage. Crystalline structure may not be like that. Crystalline structure may not allow you to go in unless the content is much smaller than the crystallinity and distance to distance, okay? So that's where material science, then physics, chemistry, all becomes helpful to engineers. Reaction of cementitious product formation in concrete. Now, without addition of fly ash, concrete cementitious products are formed at room temperature. When cement and aggregates add together, water is also added because that's what is in concrete. As soon as water and cements come in contact, hydration starts, and during this hydration process, a glue forms that binds sands and rocks together. So now, where the sand and the glue or the cement, they are all separate. When you have the water forms a chemical bonding between the sand and rocks. The glue is nothing but calcium silicate hydrate, gel, and this is the main product of hydration of Portland cement. And it is primarily responsible for strength increment base material. And the reaction is given below. Portland cement plus water is CSH, calcium silicate hydrate, plus some free lime. Along with this CSH gel, hydration of Portland cement produces another product, which is calcium hydroxide, which is called as free lime. Now, so cement looks so easy but so valuable, but it also has a very nice chemical reaction series. Now, this free lime is not durable. That means it is not very strong or things like that. It concretes more brittle, and thus it reduces its durability. If you have free lime, the calcium hydroxide, it is not. And so what he's trying to say that if you have concrete and if you do analysis and if you find that it has more calcium hydroxide, then for a long time, and durability means under load. Okay, let me go there. Durability, if you are talking with a chemist, chemistry durability means perhaps compositions change. If you're talking with an engineer, durability means perhaps there are cracks are generated and that the strength goes down. And to me, they are combinations of both. Okay? So that means if the structure changes, that can create, if the composition changes, it can change the volume. Is that right? Is the volume of two components always the same? No. If the composition changes, that means the material from change one chemistry to another chemistry, the volume may change. And if volume may change, it can either cause, if the volume goes up, then it will put compression. If the volume goes down, it will be back, so it might cause tension. All right? So that's where science and engineering is very clever. And when I see this over the past 5-10 years, like there's institutes of engineering, what is the IEE? Institute of Engineers. No, not institute, no, the Indian engineer, what is all this different IEEST, what does it mean? Indian Institute of Engineering and Engineering, Science and Technology. So now that is what I like about it. They are getting science and engineering and technology together. And that's what is very, very good. Okay? Like, I think they have thought about it. And it is likewise, while you are applying or generating structural materials, it has to be engineering, science and technology together. Now, to handle excessive amount of free lime, fly ash is added, because excessive free lime can cause difficulty, but if you add fly ash, then it can handle that situation. In early days of 20th century, fly ash was used only for mass production to delay heat of duration. But nowadays, fly ash is used in every concrete application to reduce amount of free lime. So earlier, fly ash used to delay the heat of hydration because then heat would have generated very quickly. But these days, fly ash also is used to handle the free lime. So we'll go to the next slide. I'm not pushing anything because we have people of such talented, we have such talented audience. So it's just we all interact with each other also, okay? And that is one reason why I think the GAN program, they always they have a limitation that the audience should not be more than 50. Unlike in conferences where people can, but I know the GAN said that the audience must not exceed the number 50. So they want interaction and, okay? Government of India is very clever. Okay, with addition of fly ash, small amount of fly ash in concrete can reduce amount of free lime generated during hydration. Fly ash also forms strength, providing the CHS gel by reacting with free lime. And now the reaction is shown below, reaction of powdered cement and fly ash. So you add fly ash, leads to calcium silicate hydrate. So there is no free lime. Remember in the earlier one, there was a free lime here. Now when you add the fly ash, there is no more free lime. Can you see that? Okay. And this table is just a reminder. Okay. In cement, calcium oxide content is very large, as we have seen before, about 64%, and silicon dioxide content is only about 22%. Available amount of silicon dioxide reacts with calcium oxide and forms this CSA gel, and remaining calcium oxide forms free lime on hydration. On the other hand, this is normal cement. On the other hand, in every pozzolan material, cement oxide, silicon oxide content is large, and calcium oxide content is low as compared to cement, the other pozzolan material. So thus, silicon oxide reacts with all CaO and forms that gel, and still some amount of reactive silicon oxide is present. I have, in our department, there are people of different background, and there is one guy, he's a ceramic, professor of ceramic, and he happens to be, his name is Charles Sorrell, Chris Sorrell or Charles Sorrell. If any of you are interested to go and work with him for some time, or visiting, you can write to him, okay? C. Sorrell, S-O-R-R-E-L-L, and you can mention my name that I provided. You mention that Dr. Bando, all right? And he's an elegant American. And Sorrell and I were extremely good friends, all right? So, C. Sorrell. What is the chalk box? I'll write down his name. And he currently has one good Indian boy who, Pramod Kochi from Kerala, he did his PhD in our school, and he is a good research associate of Dr. Pramod Kochi of Charles Sorrell. So ceramic expert. Is light थोड़ा on कर देंगे? उन्होंने Charles C. Sorrell, and his email is C. Sorrell at UNSW EDU and AU. In some of in number of my fly ash recycling papers, his name is there. He has not been directly involved in the research, but he has given valuable information to my student, and I'm thankful to him. Sorry, this is at, this is not, like you say, at the rate of. unsw.edu, this is Australia, AU. Professor Charles C. Sorrell. Yes. Now I ask the question, what does AU means? That's what I, huh? No, but what is not, just now Professor Kamal Kaur was talking about you, what does AU means? Gold, that's what I tell my students in Australia. You are in a country which represents gold. Of all the countries in the world, only AU, Australia, has the symbol of AU. And I say, always remember, don't have any corruption, don't make any corruption, work hard and you'll always be there. So that's what I say that is. And I always try to make sure wherever I go, and I make sure that Australia is known as a gold country. All right? You may say, sometimes you may think, I'm biased. No, I'm not biased, because wherever you go, like when you work for India, when I come to India, I'm also an Indian. So I work for India. Anywhere in India, I would like to go and get part in this thing and improve India. All right? So to me, Australia is a gold, India is indium. Indium is also a valuable material, isn't it? All right, light off कर दीजिए. मेरा हिंदी थोड़ा बनारसी हिंदी है. मेरे दादाजी बनारस में रहते थे. कहाँ पे रखा वो चीज? कोई है? आप लोग के अंदर कोई बनारस से है? गुड. आप भी बनारस से? धन्यवाद. Okay. On the other hand, in every pozzolanic material, silicon oxide content is large and calcium oxide content is low. So the silicon oxide reacts with all CO and forms the gel. All right. When I make the slides, I spend a lot of time in highlighting the different aspects, because otherwise when I myself read, I get lost. All right, if everything is in the same color. And my wife said, you make one slide and you take 4 or 5 hours. I said, yes, these slides take that time. Okay. This way, what it says, fly ash not only replaces cement in small amount, it also increases the durability of concrete by removing free lime content from concrete and thereby increasing the strength. So remember in the earlier equation, there was free lime, but when you put fly ash, lime is gone. Okay. चाय तो 10:30 बजे मिलेगा ना? We still have good 25-30 minutes time. ठीक है. मेरे को तो चाय थोड़े से मिल गया, लेकिन वो खत्म हो चुका. Difference between class F and class C fly ash on reacting with Portland cement. Now, depending upon the elements present in the fly ash, and that's what I showed you in the repeated table 2, for those different, not just one fly ash, we had taken fly ash from 4 different, and I had actually sent my then PhD scholar, who is now Dr. Ahmad Zari, I sent him to that cement, go to all the things, and when he came back, his knowledge went up so much, okay, and he could see what is happening. So again, similarly, I would respect you people and request you people to see if you can visit coal power plants and see what kind of fly ash they produce and all the things, okay? You have, so that will make your knowledge much more long term. Now, class F fly ash, where you have less calcium oxide, and class C fly ash show different reactions with Portland cement and show different advantages and uses as follows. If you say class C fly ash, class F fly ash, it has low calcium oxide content and it shows most effectively moderated heat gain during concrete curing. Thus, it is known as most ideal cementitious material in mass concrete and high strength mixes. So, low calcium oxide content fly ash is very useful. This behavior of fly ash, class F fly ash, is useful to solve summer concreting problem, because in summer the temperature is very high, so reactivity may become very much. So those things are quite. Now, depending on where you are in summer. I've never been to Middle East. I think summer and winter have both similar temperature. Maybe summer has 50 and winter may have 45. Is it right? Anyone have been to Middle East? Anyone have been to Middle East? No? I felt sorry yesterday. You have been to Middle East? Which country? Oh, you are in UAE. Unit. Okay, okay. Oh, the new. Okay, so I got the new information. Okay, because I was told that winter is also very hot there, but it's not like in Dubai. Okay, thank you. So next time when I like to go there, I felt so bad. I mean, when I talk about Dubai, we got the newspaper, and when I opened the newspaper, it shows Sri Devi is gone, and she was in Dubai. I said, oh my God. I felt so sorry. I thought it was very hot there, but so it's not that hot. So high temperature did not cause the problem. So, all right. Wonderful lady, isn't she? Okay. Also, class F fly ash also shows better results to oppose sulfate and sulfide attack. So this class F fly ash is recommended where concrete is subjected to sulfide or sulfate attack, such as in contact with soil or water. So often when there are soils and there is water, and water composition in the soil is different in different places. So we went through class F fly ash, and let's go through class C fly ash. Class C fly ash concrete is susceptible to higher earlier strength than class F fly ash. So if you need higher early strength, class C fly ash is better. This class C fly ash is used where early high strength is required, because often concrete generates strength, sometimes people say 28 days. You're all right? Oh, you're one hand you're writing the pen, the other you're holding the mobile. Oh, good boy. I for whatever reason, when I see people are walking, crossing the road, they're having them. That's why I don't use a mobile which I don't use any mobile. I have a mobile, just phone call coming, but I don't use this iPhone or things like that. All right. But these are my students who did a PhD. One day, Mike and mother he was from Karnataka. Something like this, sir. He got a message. What? He said his bank has sent him a message. Something like that. So if you don't go to the bank to get the message, he said, no. Everything comes on the iPhone. Okay? Do you all use iPhones? Is it easy to use iPhone? What does I mean? Information phone? Or, huh? What does I mean when you say iPhone? Internet phone?
Yes.
Internet phone. Most, okay, thank you. Now, high calcium oxide containing class C fly ash has self-hardening characteristic property and does not require any extra lime during soil stabilization. So this is the major use of fly ash. So it's an independent strengthening agent. It does not need anyone because it has high calcium oxide. So that itself does all the reaction. Okay? It's like Professor Kamalkar. He's a class C fly ash. He does not need others to work for him. He does all the work himself. All right? That's what I have seen him. It's a nice one. So you can tell him, sir, you're the class C fly ash. All right? But don't have suggested. But he is like that. He works everything himself. His students help him, but eventually he does everything. Okay. STM Flash Specs, specification for better quality concrete. American Society has assigned some specification for the use of fly ash in concrete, depending upon the fly ash parameters like chemical contents, LOI, loss on ignition, particle shape, particle size and shape with control quality of concrete, and other properties. So these are given in table 8. This shows specification of mineral admixture. So if you have type N is not the fly ash from the thing, it is the normal pozzolan. Type N, type F, and type C. So these two have these three combined about 70%. Then here, this is about the same. Moisture is about the same. The LOI here, the type N has very high residual carbon, whereas type M maximum is about 6% carbon. And available alkalis are typically. So this gives some idea about the two types of fly ash and also the type N pozzolan. Chemical specification, as we have seen in table 8, this silica alumina Fe2O3 content of fly ash should be high. It is about 70% to reduce maximum free lime in concrete. So this is what is required. So maximum free lime in concrete, which reduces strength of concrete and to form CSH gel to improve strength and durability of concrete. Because if you have more of this CSH gel and no free lime, then it improves the strength and durability. Strength is one thing. What does durability means? So durability, does it mean strength is properties are going up or are coming down? What are you concerned about? Can you say that again? Okay, so durability means it should maintain this certain level of strength and properties for a long time. So if it starts coming down, then it's not accepted. But if it starts slowly going up, it's better. So durability means that length till which it maintains its expected properties. Okay? Now ASTM, this standard permits maximum SO3 up to 4, 5, and again for class N, class F, and class C fly ash. Higher this SO3 content, higher will be the early age of strength, but excessive amount of that in hardened concrete can cause internal sulfate attack, which can result in disruptive expansion. So if it gets expansion, then it can create some stress. It can create some, in some cases it can be good, it can create compressive stress, but sometimes if it expands and if there is a crack generated, then it will reduce the fracture strength. Okay. The maximum limit of SO3 content of fly ash is also decided. Similarly, maximum limit of LOI of fly ash is assigned as previously. So 6% for class F and 6% for class C. And they are the normal N-type polymer, it goes up to 10%. And the main element of LOI is unburnt carbon. What are required for workability of concrete depends on two factors: amount of unburnt carbon, which is there in the fly ash particle size, or porosity of particle in fly ash. Some fly ash actually can have, the particle itself may have hole. And what is it called? It starts with XENO, xenosphere. XENO pH. So some fly ash can have actually voids in that. That is what is known as, some fly ash can be, the particle looks good when you're doing STM, but inside that it has hole. That means its weight, the weight of those fly ash particles is much less. It can be good or it can have other defect, but it's worth knowing that. So xenosphere, can you, XENOSPHERE, xenosphere. That is the porosity of particle in fly ash. Water demand of concrete increases with increasing amount of unburnt carbon content. Now, the dosage of air entraining admixtures of fly ash concrete increases with increasing unburnt content. So, if you have more unburnt content, LOI is high, some of these things is worth keeping in mind. Why does it do? Because carbon tends to absorb organic admixtures such as air and training agent, because carbon is very active. Carbon is very active, okay? So that's why we have, in our bodies, everywhere there is carbon. Even burning something, carbon generates the energy. So wherever there is carbon, it is very active. So even in the fly ash, if you have more carbon, people might think, well, it's not an oxide, but it's very active. All right? So keep that in mind. In the same manner, porosity affects water demand and so as porosity of fly ash increases, that means if you have more xenosphere, please make a note, water demand and dosage of air entering agent increases. Thus, to control water demand in concrete curing, LOI of fly ash should not be more than a certain that assigned as in the standards. Because if you have more carbon, then all these things will happen. Physical specification of fly ash, specific gravity or density, fineness, particle size, and mineralogical composition. If you go quickly to specific gravity and fineness, specific gravity of fly ash is varies from 2.1 to 3. What is specific gravity of water? What is specific gravity of aluminium? Good. What is the specific gravity of steel? All right, 7.5. Sometimes you may 7.345. Okay, so it's like that. Specific gravity of Portland cement is about 3.5. That means if you're using fly ash for the same volume, the weight or the heaviness of the cement or the concrete will go down by a certain percent. Even if it goes down by 10% or 20%, it will be good. For better quality of concrete fly ash is selected that have specific gravity around 2.2. So normally, if it goes from 3.15 to 2.2, it's about 1/3, 30%, 33% down, something like that. So you can use the truck. You can take more material. And it's lightweight. Okay. Lightweight is very important. Like I mentioned yesterday, this 787 plane which comes, it has much lighter structure. It has this composite structure. That's why it can fly for about 12 hours or so, something like that. Fineness of fly ash particles, very important parameter that affects quality of concrete. So pozzolanic activity of fly ash is directly related to the fine. So fineness of particle, remember yesterday I showed several SCMs, and in future lectures also micro. Always try to use SCM. If you use just normal optical microscope, you can do that, but advantage of scanning electron microscope is the depth of field much better, much superior, okay, compared to the, if you go to for the same magnification, if you go for 200 times in the optical microscope, you can only see very top flat. So the depth of field is not much good. Now, pozzolanic activity, that means absorbing the water, is really related to the fineness of the particle and amount of the finer particles. That means how much you have. Particle size larger than 45 microns shows less or no pozzolanic activity. This is very important. That's why you need to use, when you're using fly ash there, look at the thing, or if you see a wide range of particles, you can save it. You can save the particles which are smaller than 45, and then you can use the rest of them for other things. Save the particles. You are familiar with sieve? आटा sieve करते हैं घर में. Okay, so sieve. Everyone familiar with sieve? Sieve को हिंदी में क्या बोलता है? छन्नी. Okay, okay. छन्नी. Okay, thank you. So use the proper sieve to make sure that you get the particle size less than 45, all right, micron. Okay. Fineness of fly ash ranges from less than 2% retained to more than 30% retained on the 45 micron sieve. So use that. ASCMC has the class C fly ash has limits, no STMC, that's a standard, maximum 34% of the amount of material required retained on a 45 sieve. So if on the top of that, if the sieve is retained on the top, that means their particle size is larger than 45 micron, okay? So these things are very important. So people, if you just have fly ash, and sometimes people think, just go and dull, but no, these are the properties. That's what science and engineering is. Okay? So you need to, it has to go through the particles and your size and everything. That's what I like about this fly ash recycling. Manganese and free lime in cement or fly ash cause disruptive expansion of concrete. So it is worth keeping in mind. To avoid the expansion and to ensure proper soundness, autoclave expansion test is employed. In this test, maximum permissible expansion must be less than 0.8%. So these are the standards. So if you are working on fly ash, it is worth buying some of this equipment. All right? Advantages of using. We'll go for another 5 minutes, and then we'll have tea break. All right? Use of fly ash in concrete not only saves Portland cement, but also improves the quality and other properties of concrete. The following gains in concrete properties are also achieved. Fly ash contributes to concrete strength, concrete durability and strength, improves concrete workability, protects the concrete from chemical attacks. Fly ash reduces heat of hydration in concrete. So it becomes an engineering gold. That song of mine, fly ash, fly ash, fly ash, I'll try to find out the thing. At the end of that, so make fly ash, use it as an engineering gold. Okay? So I'll get that in somewhere in my one of them. This song came into my mind when we organized this ICUFA conference, International Conference of Utilization of Fly Ash by Pollution Control Board and in Kolkata. So we had DST, Dr. Vimal Kumar. He's a great man. He couldn't come to this meeting today because he's elsewhere. So he has told me that he will miss meeting you people, but he's a great man. If you want to know his name, you can. His name is Dr. Vimal Kumar. He lives in Delhi, so not far away. You can approach him through DST if you wish. But then he asked me to send him this JN website because he will try to follow it up. And for this week particularly, he's elsewhere. How fly ash can assist in achieving these advantages? Environmental benefits is one. By using fly ash in concrete, it saves land and improves fertility. Then use of fly ash in concrete is very beneficial to keep environment clean and healthy. Using fly ash in concrete avoids dumping of fly ash in landfills. Thus it saves lots of land. And also not dumping fly ash increases soil fertility in most of the cases. So that is useful. The reduction in carbon dioxide emission by adding fly ash in cement. So that is, the presidents all different countries will jump up. So if you send that information to Sri Narendra Modi, he will jump up and will say, let's form a fly ash. Okay? I send this information about this GN to Sri Narendra Modi, but I receive email from Prime Minister's office regularly, but it says no reply, so you cannot. But then I went to the website and I found an email of Sri Narendra Modi, personal email on Gmail. So I sent this information and I gave that website. So you are all in his mind, okay? So if he later follows up, he may take some time, make him come here and he can see what attendees and all this list. So the reason why I do it, I think it is important. It may take months and years, but you have to do things, all right? So, and that email which I sent to him, it did not get. Sometimes if you send an email and it says, sorry, we could not deliver it, but no, it was delivered. And I did that and I mentioned about this institute and EN program and the quality and all this website. So Sri Narendra Modi knows that you are all here. Sometimes you never know on the holiday he might send someone. Have I done the right thing by sending him the information? Huh? And so you also do, I suggest all of you do the same thing. Do it as a group of engineers and things like that. Keep him informed because I can see. I first came to know about him when I was in Gujarat 2006 in Atira and then went back there 2007 and 2009 promoting nanotechnology and STM nanotechnology courses. That's when, so they showed me where his house is and someone said the area of his house land is 1 kilometer square. I said that's good. But he has made Gujarat a lot of things and he has been promoting India. In fact, I remember when he became Prime Minister, he went to Australia in Sydney, and there was he has a general lecture, but there was also in 1 hour, so the selective lectures, about 100 people, we could meet him. So the consulate general thankfully asked me to go and meet him. So I could see him right from the front. So, and that's what I did about 2 weeks ago. Mr. Prime Minister, this flash thing again is going up. So please try to come or follow it up. All right? So you are all on in his mind. Okay, reduction of carbon dioxide, and this is very, very good. I mean, people who are not engineers, to them engineering other things, but if you say that to the politicians, reduction of carbon dioxide emission by adding fly ash, so it's a fantastic thing. Production of each ton of cement releases a ton of CO2. In this manner, cement production contributes about 7% of global carbon dioxide emission. And then this happened in 2 ways. By heating of limestone to produce cement, this needs large energy and releases large amount of CO2, and direct chemical reaction that occurs during heating of limestone. So this is how these things happen. As fly ash, it can replace some amount of Portland cement. Production of Portland cement can thus be minimized. So even if it can be reduced from 7% to 6% or 5%, that is you're reducing by 14% or 15%. So it's a huge thing. So use of fly ash in concrete minimizes the amount of CO2 addition. And it is said if all the fly ash generated each year is used in concrete, then the reduction in carbon dioxide emission would be equal to eliminating 25% of carbon dioxide emission of the world's vehicles. I think we'll stop here. And then we'll have a tea break, and then we'll come back. Has it been informative, this lecture? Very informative? Thank you. It's a lot of areas, but even we cannot, each one of us cannot use all these areas. But even if you can use, or we can use even 1%, 2%, or 5%, then there are so many people. 5 times, if you multiply by 40, it becomes about 200%. Or even if you were to use 1%, 1 time multiplied by 40, it becomes 40%. Fly ash from coal power station. People call it a waste material. I don't like that notion. Fly ash, sing with me. Fly ash, a valuable source of ceramics, fine and coarse. You can use it in a micron size or a nanometer, a mil down price. About 6.8 gigajoules. And so if we replace Portland cement by fly ash, say even 30 to 40%, that will save a loss of thermal energy. Okay, so that will also be a very saving commercial advantage. The decrease in permeability, fly ash helps to keep permeability of concrete low. What is permeability? Permeability is defined as the rate at which liquid is transmitted through a saturated specimen of concrete under an externally maintained hydraulic gradient. Now, increased permeability of concrete is not acceptable, as strength and durability of concrete depend on permeability, and there is inverse relationship between these 2 factors. So this strength and durability, these 2 do not match each other, so they attack each other. So as permeability increases, then the stability of concrete decreases. So, and as permeability decreases, the strength of concrete also is not improved. Okay, so these are the things which happen. I think that's the last slide in this section, and we'll go to the next one. Professor Kaur. It's only this year.